Yeah, we are back on the preparation. How do we solve problems involving reaction rates? I'll just do one question paper example here, and then hopefully while we are doing that, we're going to learn a lot out of the whole exercise. There was a question. This section of reaction rates is normally on question number 5 in a normal question paper. This was question number 5 in one of the examination papers. It says, learners use the reaction of magnesium carbonate with excess dilute hydrochloric acid to investigate the relationship between temperature and the reaction rate. Remember, in this section, all the 5 factors that affect the reaction rates are independent variable, and there's only one dependent variable in this section, which is reaction rate. The equation is given, balance equation: magnesium carbonate react with 2 moles of HCl to form 1 mole of magnesium chloride, 1 mole of carbon dioxide, 1 mole of water. The results obtained are represented graph below. The graph is that of average rate of production of carbon dioxide in grams per minute, very important that, versus temperature. The first question, they're saying to us now, 5.1, define the reaction rate of reaction. Remember, there are many definitions. In this case, I'll just go for the easiest one, 2. The first one can be, it's a change in concentration. Change in concentration of reactants or products per unit time. Change in concentration of the reactants or products per unit time, or one can just use the formula of saying the average rate is delta C over delta T, just to say the reaction rate will be the rate of change in concentration. Okay, 5.1 we are done. 5.2, they say state 2 conditions that must be kept constant during this investigation. Remember, to make the experiment, in this case, fair, while we're investigating one factor, we have to make other factors constant. In this case, we're investigating temperature, therefore the other factors must be kept constant. One of them will be the concentration of HCl, if you want to be explicit, and then the other one will be the state of division of magnesium carbonate. I think those are the 2 most important ones. Now we are coming to 5.3. They are saying to us, use the collision theory to explain the relationship shown in the graph. Now you can see the relationship. Remember, collision theory, we've got 4: temperature, catalyst, concentration, and state of division. Now here we are using the temperature. Temperature, as the temperature increases, you can see that the reaction rate also increases. Therefore, we're going to start increase in temperature according to collision theory, increases the average kinetic energy of particles. That's the first point. The second one, therefore, once the average kinetic of particles, therefore more particles have will have enough kinetic energy. Remember, what is enough kinetic energy? Is the kinetic energy that is greater or equals to the activation energy. Then the third mark will be once more particles have got enough kinetic energy. Yes, yeah, we were on that one of saying more particles will have enough kinetic energy, therefore more effective collisions. More effective collisions per unit time. Per unit time. In this case, be careful, per unit time, or you can say the frequency of effective collisions also will increase, or you can say per second, more effective collisions per second, or the number of effective collisions increases per second. And therefore, once this one, therefore, hence the reaction rate increases. Reaction rate increases. Fine. That is 5.3. And then now let's go to 5.4, which is the last part in this one. For 5.4, 5.4. Now there are two. There's 5.4.1. Now they are saying to us, the learners obtained the graph above using 5 grams of magnesium carbonate with excess HCl at 40 degrees. Now calculate the time taken for the reaction to run to completion. Now in this case, the rate is measured on carbon dioxide, therefore we need to use the magnesium carbonate to find the carbon dioxide, how much of carbon dioxide will be used up, will be produced, and then we can calculate the rate from there, because on the graph we are given carbon dioxide, not magnesium carbonate. Now we know that the mass of magnesium carbonate is 5 grams, therefore it means that now the whole 5 grams will be complete, will be used up. The number of mole of magnesium carbonate will be the same as given mass over the molar mass, which is 5 grams. Magnesium carbonate will give us 84. Therefore, the answer here will give us 0.06 mole. Now we are relating, we can use magnesium carbonate to find the number of mole of carbon dioxide. So that number of mole carbon dioxide is the same as the number of mole of magnesium carbonate, because they are in the ratio 1:1. Therefore this will be 0.06 mole. But we don't need mole in carbon dioxide, we need mass. Therefore the mass of carbon dioxide will be the same as number of mole multiplied by the molar mass, which is 0.06 multiplied by 44. This gives us 2.64 grams, meaning that at completion the mass of carbon dioxide that will be produced will be 2.64. Now we can go back to the rate at 40. According to this one, at 40, if you run this one, you'll find that now the rate will be 0.5. So average rate will be delta M over delta T. The average rate is 0.5 according to the graph. And then changing mass of carbon dioxide, remember we started with 0, we finish with 264. It will be final mass minus the initial mass, all divided by delta T. Therefore delta T will be, when you use this one, it must give us somewhere around 5.28 minutes. So this will be the time taken for the whole reaction to run to completion. You get 6 marks there. 5.4.2, which is the last one, they say to us, calculate the molar gas volume at 40 degrees if only 1.5 dm cube of carbon dioxide is collected. Now we are just going to say we know the formula where we get Vm, number of mole of carbon dioxide, will be the same as V over Vm. We know the number of mole of carbon dioxide that was produced in this hole is 0.06. 0.06 equals to V, the volume that is produced is 1,5, then we need Vm. If you use your calculator very well, you'll find that the molar gas volume will be somewhere around 25 decimeter cube. I hope we are enjoying this section. That's the section of rates. It's not always that you'll be calculating the number of mole in this formula. You can be given the volume and number of mole to find the Vm. Also in this case, it's not always that you'll be calculating the rate. You can be given the rate and then they say calculate the time taken. I hope you also learned how to explain using collision theory in the case of temperature. Definition of a temperature. Remember, temperature is defined as the average kinetic energy of the particles. Therefore, when the temperature is increased, the average kinetic energy of the particles increases. Therefore, more particles will have enough kinetic energy, more effective collisions per unit time, and then the reaction rate increases. Thanks a lot, and we'll do some more exercises in the chemistry in the sessions that are coming. Thanks and good luck in your preparation. Thank you.